Welcome to this comprehensive guide on building a two-player arena game in Unity 3D designed specifically for beginners. We'll cover everything from project setup to network synchronization, creating a local host and client experience. Our goal is to equip you with the skills to create a simple yet functional two-player arena, allowing players to connect locally as a host and a client, and to understand the fundamental concepts of networked gameplay in Unity. Our goal is to equip you with the skills to create a simple yet functional two-player arena, allowing players to connect locally as a host and a client. This process begins with opening Unity Hub and initiating a new project, which is the very first step in any Unity development endeavor. We will be selecting the 3D Core template to ensure we have the necessary foundational elements for our game. First, open Unity Hub and create a new project. Select the 3D Core template, which provides a solid foundation for 3D games, and name your project Two-Player Arena. It's crucial to choose a suitable location for saving your project files to keep your workspace organized. This initial setup is vital for a smooth development process. Next, we need to install essential packages for networking. These packages are not included by default and are critical for enabling multiplayer functionality. Navigate to Window, then Package Manager within Unity. The Package Manager is where you can find, install, and manage Unity-developed and third-party packages that extend Unity's capabilities. In the Package Manager, search for and install netcode for game objects. This package forms the foundation for our networking capabilities, providing a high-level API for network communication, object synchronization, and player management. It simplifies the complexities of multiplayer game development, allowing us to focus on game logic rather than low-level network protocols. Ensure your Unity version is March 10th, 2021 or later for compatibility with netcode for game objects and other modern networking features. After successfully installing netcode, proceed to install the Unity Transport package. This package handles the low-level network communication, acting as the backbone for data transfer between clients and the host or server. Optionally, if you plan to use Unity's modern input system, which offers more flexibility and control over player inputs, install the Input System package as well. While not strictly required for basic networking, it's highly recommended for a more robust and future-proof input solution in your game. Now that our project is set up with the necessary packages, let's build our arena environment. Create a new scene by going to File, then New Scene, and name it Arena. This new scene will serve as the primary environment where our players will interact and compete. Add basic 3D objects like cubes to form the floor and walls of your arena. You can easily find these primitive shapes under Game Object, then 3D Object. These simple shapes will allow us to quickly construct a functional layout for our game, which we can refine later. Scale and position these objects to create a simple yet effective arena layout. Think about the dimensions and flow of your arena, ensuring enough space for player movement and interaction. For a more visually appealing environment, consider importing a pre-made arena model from the Unity Asset Store, which can save significant time on asset creation. Crucially, ensure all arena objects have colliders so players cannot pass through them. Colliders are essential for physical interactions within the game world. Add box collider components to your floor and walls to define their physical boundaries, preventing players from falling out of the arena or moving through obstacles. Adjust the scene's lighting for better visibility and atmosphere. A well-lit scene enhances the player experience and makes the environment more engaging. Add a directional light from Game Object, then Light, and fine-tune its rotation and intensity to achieve the desired illumination and shadow effects within your arena. Now, let's set up our player prefab, which will be the blueprint for all player instances in our game. Create a new 3D object, such as a capsule or cube, to represent your player. This object will serve as the visual and physical representation of a player in the arena. Add a character controller component to this player object. The character controller is a specialized component designed for player movement and collision detection, providing essential collision detection and basic movement capabilities without the complexities of a full rigid body physics simulation. For networking, add a network object component to the player. This is vital for managing its network identity and synchronization across all connected clients and the host. The network object component assigns a unique ID to the player, allowing the networking system to track and update its state over the network. Also, add a network transform component to synchronize the player's position and rotation across the network. This component automatically handles the replication of transform data, ensuring all players see each other in the correct locations. For more advanced scenarios, consider client network transform for client-side prediction, which can reduce perceived latency. Create a new C# script named player controller and attach it to your player object. This script will be responsible for handling all player-specific logic, including movement, input processing, and any other actions your player can perform within the game. It's the brain of your player character. Implement basic player movement within the player controller script using character controller, move. This method allows you to move the character while respecting collisions. You'll take input from either the input system, if you installed it, or the older input manager to translate player commands into movement within the game world. To create a reusable template, drag your player object from the hierarchy into the project window. This action creates a player prefab, which is a pre-configured game object that you can instantiate multiple times in your scene. Prefabs are crucial for efficient game development, allowing you to easily create and manage multiple instances of the same object. Now, let's set up the network manager, which is the central component for managing network connections and game state. Create an empty game object in your scene and name it Network Manager. This empty object will serve as a container for our networking logic. Add the Network Manager component to this new object. This component controls the overall network state of your game, including starting and stopping the host, server, and client, as well as managing player connections and disconnections. It's the orchestrator of your multiplayer experience. For a basic UI to control our network connections, add the Network Manager HUD component to the Network Manager game object. This provides simple buttons to start and stop the server or connect clients, allowing for quick testing and debugging of your network setup without needing to build a custom UI immediately. In the Network Manager component, assign your player prefab to the player prefab slot. This tells the networking system what object to spawn for each player when they connect to the game. It ensures that every player joining the session gets their own instance of your carefully crafted player character. Next, create 3 UI buttons: server, host, and client. These buttons will allow us to manually control the network state for testing purposes. Use the canvas to create the UI elements, ensuring they are visible and accessible within your game's interface. Write a C# script to control these buttons and their corresponding network actions. The server button will call Network Manager, singleton.startServer, initiating a dedicated server instance. The client button will call Start Client, attempting to connect to an existing server. And the host button will call Start Host, which starts both a server and a client on the same instance. To test the connection, build your project. This will create a standalone executable of your game. You can then run one instance in the editor as a host and another as a standalone build as a client, or run 2 standalone builds to simulate a real multiplayer scenario. In one instance, start as a host, which will act as both a server and a client. In the other instance, connect as a client. You should then see 2 player instances in the scene, one controlled by the host and one by the client, confirming a successful network connection and player spawning. The Network Manager should automatically spawn player instances upon client connection if configured correctly. If not, you might need to manually spawn them using Network Server, spawn within your network logic. This ensures that every connected player has a character in the game world. For player synchronization, it's crucial to wrap your movement code in a network behavior within the player controller script. This ensures that the script is aware of the network context and can properly synchronize data across all connected instances of the game. Use network variable vector3 to synchronize the player's position, ensuring that all clients see the player in the correct location. Additionally, implement server RPC and client RPC for movement commands. Server RPC allows a client to request an action on the server, while client RPC allows the server to command an action on all clients, facilitating synchronized movement. Crucially, only apply movement on the client that owns the player object by checking his owner before processing input. This prevents other clients from controlling your player and ensures that each player only controls their own character, maintaining proper game logic and preventing unauthorized input. Test synchronization by moving players in both instances of the game. Their movements should be smoothly replicated across the network, appearing consistent and responsive on both the host and client screens. This confirms that your network synchronization is working as intended, providing a seamless multiplayer experience. For final touches, add non-copyrighted background music to enhance the game's atmosphere and immerse players further. Music can significantly impact the player's emotional experience and make the game more engaging. Ensure the music is royalty-free to avoid any copyright issues. Ensure captions are enabled in your video editing software for accessibility and clarity. Captions make your tutorial more inclusive, allowing viewers with hearing impairments or those who prefer to read along to fully understand the content. They also help reinforce key information. Remember to use stock media for introductions and conceptual explanations, providing a professional and engaging visual backdrop. For all tutorial steps, use clear and detailed screen recordings of Unity and Visual Studio to guide viewers through the practical implementation, ensuring every step is easy to follow. Finally, thoroughly test your game to ensure the host and client connect seamlessly and player movements are smooth and synchronized. Comprehensive testing is vital to identify and resolve any bugs or network issues, guaranteeing a stable and enjoyable multiplayer experience for your players. Congratulations! You've successfully built a two-player arena with local host and client functionality in Unity 3D. This is a significant achievement, providing a solid foundation for more complex multiplayer games. Keep experimenting and building upon these skills to create even more exciting projects.